All right, thank you, Tomek. Good evening, everyone. My name is Piotr Święcicki, and I'm going to describe tonight something more about how things work. This is actually our second episode under the same title. Last time we discussed various things. We talked about how planes fly and why we cough and a few other things. But for the purpose of this session, I thought that maybe we should take one step back and start with the basics. Okay, I got this idea when I came across a short article in which I found this pie chart. And in this pie chart, you can see something very interesting. It's the distribution of chemical elements in our universe. And as you can see, 70% of our universe is built out of hydrogen. 25% is built of helium, and 1% is all the rest. So this got me thinking, I have to do something completely different this time. But before we begin, I'd like to ask if you can hear me. So if you could use the chat box one more time, the question box, and well, you can write anything. You can write hello, yes, or universe, or hydrogen, or anything. Can you hear me, guys? Thank you very much. Thank you, Anna, and many others. All right, so let's begin. Our journey will last something about 25 minutes up to 30. There will be some scientific information for you, but also language puzzles and language games. So let's begin. Okay, folks, that's our universe. And well, some of you probably know that the universe began with one single chemical element, and the element is hydrogen. And hydrogen created the stars, and stars created all the other elements we need for life. Really, everything was created by stars. Oxygen in the air and calcium in our bones, it all really came from stars. But the question is how? And it is quite astonishing to think that all the ingredients necessary for life were created inside them. And the truth is that every star is an immense factory churning out billions and billions of chemicals. But the chemicals aren't much use to anybody if they are in the star, of course. So luckily for us, stars don't last forever. Well, it's not so much lucky for the stars, actually, that they occasionally explode. Now, let's take a look at this picture. What you can see here is the Orion constellation. Now, do you know the name of this star marked with the pink arrow? Please use the chat box if you know the name of this very bright star. Okay, I can see some interesting answers, and Adam, that's a very good answer. This bright star in the Orion constellation is called Betelgeuse. Please don't confuse it with the name of a funny film from the 90s. The spelling of that word is a bit different. Now, Betelgeuse, well, the name comes from Arabic, I think. It means the hand of a giant, and as you can see, it really looks a bit like this star was at least the beginning of the hand of a giant. So Betelgeuse is actually a dying star. It's an enormous star, and it's one of the stars in which all the ingredients of life are made. So let's take a look at this star. Before we do this, just a word of information. Some words in the slides will be marked in yellow. If you have a pencil and a piece of paper around you, maybe you would like to note them down, because in about 10-15 minutes we're going to do a language task based on those words in yellow. Okay? So coming back to Betelgeuse. Well, what we can see is that deep in its core, Betelgeuse is fighting a futile, a lost battle against its gravity, against its own gravity, because it desperately tries to stop itself collapsing under its own weight. And that's when and that's where those new elements, those chemical elements, everything that we know of, are made. And that's the sequence in which all the ingredients, all the chemical ingredients are made. Now, we can talk about at least 4 stages in which stars produce all those elements. And let's take a look at stage 1, because this is when there's still some supply of hydrogen to burn. And while the star is burning hydrogen to helium, I think this is called fusion, vast amounts of energy are released. And the energy escapes, creating an outward pressure which bounces the force of gravity and holds the star up and keeps it stable. But eventually the hydrogen in its core will run out, and at that point the fusion reaction will stop and no more energy will be released, and the outward pressure will disappear. So at this point the core will start to collapse very rapidly, leaving a shell and hydrogen and helium behind. So beneath this shell, as the core collapses, the temperatures rise to something like 100 million degrees, and this is when stage 2 starts. In stage 2, helium nuclei begin to fuse together, and helium fusion actually does 2 very important things. Firstly, more energy is released, so the collapse is actually halted. It is stopped. But secondly, 2 more elements are produced in that process, and those elements are carbon and oxygen. And as you know, those 2 elements are vital for life. So if you think about it, this is exactly when and where all the carbon in the universe comes from. And if you think about it even more deeply, you can say that every atom of carbon in my hands and every atom of carbon in your hands and every living thing on the earth was produced in the heart of the dying star. Now, in this slide, you can see a rough estimate of and distribution of chemical elements in our bodies. So as you can see, there's a lot of oxygen, there's a lot of carbon and hydrogen, and as we have just seen, well, they come from the hearts of dying stars. Right. So when compared to the lifetime of a star, the creation process of carbon and oxygen takes place really rapidly, in the blink of an eye, because in only about 1 million years the supply of helium in the core is used up. And for stars as massive as the Sun, that's when the fusion stops, because there isn't enough gravitational energy to compress the core any further and restart the fusion. But for massive stars, such as the beetle juice, the fusion process can actually continue. So when the helium runs out, gravity takes over again and the collapse continues. So the temperature rises once more and it launches stage 3. Stage 3 is also very important because this is when carbon fuses into magnesium, neon, sodium, aluminium, and so it goes on. Core collapse followed by the next stage of fusion to create more and more elements, and each stage becomes hotter and hotter and shorter than the last one. And eventually, in the final stage that lasts only about a couple of days, well, in the last stage, the heart of the star, the core of the star, is transformed to almost pure iron. And this is where the fusion process stops. In its millions of years of life, the star has made all the common elements. We can say that the star has made the stuff that makes 99% of the Earth. And the core is now a solid ball of these elements which are actually stacked on top of each other in layers. I think we can see that in the following slide. So on the outside there's a shell of hydrogen, and beneath it there's a layer of helium, and then carbon and oxygen and all the other elements, all the way down to the very heart of the star. And once that is fused into solid iron, the star has only really seconds left to live. And this is when stage 4 begins. In stage 4, that's when the star actually runs out of fuel. It can no longer release energy through fusion reactions, and then there's only one thing that can happen. The entire star falls on itself in a matter of a few seconds, and then boom, it explodes. And basically that's the end of the star, but it can be the beginning of something really interesting, because the gas and dust of a dying star can drift into space, and in time it can form a cloud full of possibilities actually, because the elements that were thrown outwards sometimes gather together and form other stars, solar systems, and even planets just like ours. So that's what you could say is a brief history of a dying star, or a brief history of everything actually. And now I'd like to invite you to discussing some language issues that were just raised, maybe between the lines a little. And here I have a little vocabulary exercise for you. 8 sentences with a single gap, sometimes a double gap in them. In brackets, at the end of each sentence, there's a little tip for you, and there's another tip for you, another piece of little help. That's the beginning of the word that is missing. Okay, so I'd like you to use the chat box one more time, the question box, and well, let's see which missing word is in number 1. Okay, let's see what's missing in number 1, folks. Please give me some answers for sentence number 1. Okay, very good, Kamil. Excellent, excellent choice. Of course, the missing word is futile. Okay, so what about number 2? Amounts of energy are released, very big amounts of energy are released. Very good. Now let me see who wrote this. Adrian and Evelina and Kamil and Jacek and many other people. Right, vast amounts of energy are released. Okay, the word vital, we will need it, but in a couple of moments, all right? Now, the supply of hydrogen, something is used up. What's the missing word? Very good, Adrian, you were the first person to say it, okay, and then many others were right. Supply of helium runs out. Very good, okay. So we move on to number 4. The core of the star collapses very fast. Jacek, Adrian, thank you very much. Right, rapidly. And now a little bit of German could be helpful. The collapse is stopped. Very good, Jacek, very good, Adrian and Grzegorz and Aldona. Right, the collapse is halted, which means stopped. Now, these are very important for life. So, okay, so now the word vital comes. Thank you very much. And the last two, the missing phrase in number 7 means more or less in the matter of a few seconds. So this happens in a something of a something, in a blink of an eye. Thank you very much, Jacek. Right. And Adrian and Daniel. Excellent. In the blink of an eye, which means very fast. And finally, that's sentence number 8. The elements are placed in layers. So first we had, what did we have first? Hydrogen and helium and carbon and oxygen and magnesium and all the other ones. Very good people. They're all stacked in layers. Now, with this little exercise, well, we have done a number of things actually. I hope that we have gone through together through something interesting. You know, the process of star death and the beginning of chemical elements. That might be something, you know, generally interesting. We haven't used any course book for, you know, teaching or learning English. We just used some stimulating scientific material and discovered that some of the words that are used in such materials can be very useful every day, even in some cases business-like words that you can just lift from a text like that and then put into practice. So so thank you very much for doing this exercise. You did really well. Now, as our meeting draws to an end, I'd like to share with you a quote from one of my favorite scientific writers. And the quote goes like this: "Every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than the atoms in your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements such as carbon, nitrogen, oxygen, iron, all the things that matter for evolution and life weren't created at the beginning of time. They were created in the nuclear furnaces of stars, and the only way for them to get into your body is if those stars were kind enough to explode. So remember, folks, the stars died so that you could be here today." And that's by Lawrence Krauss from a very good book, a book that I really recommend, A Universe from Nothing, Why There is Something Rather Than Nothing. Okay, now my last language question for you guys. Can anybody spot in this rather interesting text an example of a very interesting grammar structure, which is called past perfect. And if you can spot it, then can you just quote it maybe, or say which sentence past perfect is used in, and maybe we could just think for a while why it is used there. Okay, so can anyone spot a past perfect sentence? Right, a past perfect sentence, past perfect is used when we want to make a contrast between something that happened in the past and something that happened in an even more distant past. Okay, hadn't exploded. Very good. Now, you couldn't be here if stars hadn't exploded. That's very good. Actually, you could also say that it looks a bit like a conditional sentence, right? Like a mixed conditional. You couldn't be here, second conditional, if stars hadn't exploded, third conditional. Very good, guys. Right. So as you can see, past perfect and conditionals can be pretty handy when you read scientific texts. Okay. So let me just thank you very much for spending these 20 minutes with me. I hope that you have learned something maybe about the stars and the evolution of chemical elements, and about fusion and stuff like that. I just want to make a small recommendation. Professor Brian Cox is someone that inspired this webinar. His series Wonders of the Universe, well, I have seen it many times, and to be honest, many of the ideas which I used today are based on one of the episodes of that series. So I really truly recommend it. Thank you very much. I'd like to ask you if you have any questions which are not related to science, cosmology, because I am definitely the wrong person to ask about it. But maybe you have some questions related to language. Okay, I can see your first question. What kind of sources did you use? Well, just like I said, I watched a few videos by Professor Brian Cox. I also used a lot of Wikipedia stuff on supernovas, on Betelgeuse, and nuclear fusion. I have to admit that I haven't understood about 80% of it, but took out some gist and presented it to you. So thank you very much, everybody. Have a good evening and have a good long weekend. I truly encourage you to do some scientific research, read some more about stars, and join us for our next webinars. Thank you very much.